Now in this problem now, in the first part, we calculated the net present value of these various projects, and we ranked them according to the net present values, which told us to take project Z would be the top rated, project X would be number 2, and project Y would be number 3. The next part now, they asked us to calculate the annuitized or annualized net present value. Now to calculate that now, you take the net present value of the project, which is what you calculated in part A, and divide that by your PVIFA. And the N and the I is the N and the I associated with the project, okay, which we'll talk about in a second. When you get that answer, whatever you get there, you divide it by the firm's cost of capital, required return for the project. And this problem, they make sure they give us the same required return. You can imagine that you're talking about a 2-year project, a 4-year project, 8-year project. You know, if you have your money tied up for longer periods of time, you might think that's riskier, require a higher return. All that makes a lot of sense, but in the problem now, they make us use the same cost of capital, the same required return for all the projects. Now, the annuitized or annualized net present value for project X. And we calculated the net present value of that project to be 2701. If you divide that by your PVIFA with N equal to 4 and I equal to 14%, what you get is $927. Now, $927 is what project X would add to the value of the firm every year forever. How do you value that? Well, that's called a perpetuity. And the way you value a perpetuity is you take that annual benefit and you divide it by your required return. And so in this case, if you took 927, that annual benefit that you expect forever, so this project would add $927 to the value of the firm every year forever. That's what this is telling you. To value that perpetuity, you divide by your required return, which is 14%, and you get $6,621.43. So 6621 is the present value of that perpetuity. That is, adding 927 to the value of the firm every year forever, the present value of that additional value now every year forever, the value today is 6621. So accepting project X means what? We're going to add $6,621 to the value of the firm today. To calculate the annualized net present value for Y, we take its net present value, 1802.60, divide by your PVIFA, and you get $1,094.67. Divide that by your required return. The value of that perpetuity, adding that much to the value of the firm every year forever, is like adding $78.19.10 to the value of the firm today. And for project Z, we take its net present value, divide by our PVIFA at 8 and 14%, we get $772.49. Divide that by 0.14, you get $55.17 and 78 cents. And so when you look at these annualized net present values now, what you're doing is you're equalizing the lives. Remember, the problem here was unequal lives. And what this technique does now, it equalizes the lives in the sense that it makes them all a perpetuity. That is, they go on forever. So it's not one 2-year project, but it's a 2-year project, every 2 years forever. That's how they equalize the lives. They make it a perpetuity. And the way you value a perpetuity is to divide the perpetuity by your required return, which in this case is our cost of capital, 14%. So what you find when you do this now, when you equalize the lives, turns out that project Y adds the most to the value of the firm if you're going to be invested in these projects forever. So what was the third ranked project in part A turns out to be the top ranked project. Project X turns out to be the second project, second most desirable, and it turns out that project Z is the third most desirable. So what you see over there on the right now, this tells you the difference between the rankings using just a traditional net present value and using an annualized net present value, which is what you should do now if indeed you have unequal lives. You'll remember a problem a few videos ago where we introduced the terms timing effects and scale effects. This problem deals with timing effects, maybe some scale effects, but basically timing. Timing is unequal lives. Your cash flows go out into the future for much different periods of time. And again, the way that this is suggested that we solve this problem is to equalize the lives. The way we do that now is to create perpetuities. And then we value the perpetuities. Perpetuities all go on forever.